Let's see if this works. The video link. Hey, Nikki, how's it going? Let's get pop out chat. Make sure that works. Pop out. Hopefully everything is working. Let me check OBS to make sure the mic is on. I'm running a little bit behind today, so we're just gonna wing it. We're gonna do Advent of Code, and we're gonna see how it goes. Okay, I'll have to set that up later. I set that up on the recording thing, not the. I set up a nice new like comment highlighting thing, and I set it up on the like recording view instead of the streaming view in OBS. So, oh well. Let's see, Christopher Biscardi, Advent of Code. I think this is up to date already. So I've been doing Advent of Code for about 4 years now. We'll make another directory for 2021. So Advent of Code, if you don't know what Advent of Code is, it is basically an advent calendar, right? So if we go here, we see 25 sort of like quiz questions or whatever. And this kind of like draws a photo as we go along in the whole process. So you click on one of these and it gives you a question that you have to do. And you can do it in any language. People do this in Excel. People do this in like Rust and JavaScript and whatever. People also do this in like completely random other stuff. But you do one question, you get a star. You do another question, you get a star. For the like leaders, whoever gets the like the very first answer gets points out of like everybody. I don't usually compete for that. I usually just try to get all the problems done. So we're gonna do a few different problems this month. The guiding text is on point. Missed that. All right. So I do this in Rust. I'm going to, what did I do last year? Make a language directory and then each one. Okay, cool. Let's do that. That seems fine. Make the Rust. We could do a workspace. I don't know that we need to do a workspace. I don't know that that matters. We'll just do make dir day 1. In 2020, I did Rust day 1. And then what happened when we had two? Did I just put them in the same thing? I guess I did. Yeah, there we go. Lib part 1, part 2. Okay, so day 1. What do we have here? We'll do a cargo init VCS none because I don't need git inside this directory. And then we can just cargo run it and it'll just work. So you're minding your business on a ship at sea when the overboard alarm goes off. It looks like this is a little too wide. Oh yeah, okay, I remember that. So this is like written by, or this is designed in a way where it's like just a long thing of text and it doesn't wrap. So I remember last year, I actually put the CSS on it to wrap it myself. You rush to see if you can help. One of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Why does the sleigh have keys? Aren't we magical? There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars. Okay, so this is like intro for the whole advent of code. Like, why are we doing this at all? I guess in universe lore, if that's your thing. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Okay, as the submarine drops below the surface, automatically performs a sonar sweep. Each line is a measurement of the seafloor. So this is seafloor measurements. Report indicates the scanning outward from the submarine. The sonar sweep found depths of 199. Why is this making so much noise? This is what happens when you wake up too late. All right, we're good. First order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times the depth measurement increases from the previous measurement. There is no measurement before the first measurement, so just count how many times it increases. I wonder if this immediately makes me think of Rust or tools. I don't like when they tell a long story. Yeah, I mean, like, it's part of the vibe of the thing. I don't particularly like word problems or whatever you want to call it anyway. Because I think that more often than not, a word problem isn't about reading comprehension. It's more about having a shared context with the author of the question. But it is what it is. The input is clean again. That's good. I don't know exactly what you mean by that. Okay, so interleave is not going to be hit. Multi-peak. We're gonna need a multi-peak. I think we're just gonna need peak. I think we don't even need iter tools. I think we can just do the one peak. So let's open this. Maybe I'm too Grinch. I mean, like, it's a thing, right? I'm not somebody that likes to harsh other people's mellow. So, like, if you like the ceremony around all the questions and whatnot, then you like it. That's just how it is. All right, so this is a number of these. So let's just do like, is this big enough? Can people see the rust? Let's see, const measurements. We'll do measurements equals this. No, I didn't spell measurements wrong. I was like, I did spell measurements wrong. Let's call this seafloor so that I don't end up. I haven't had my coffee yet, so I'm just going to use simple words. Let's make this a thing of U16s. Why is it yelling at me? Do I need the length? I don't like needing to know the length. And this is going to come in. Okay, so one of the things that I'm thinking about doing is turning it into a serverless function. So let's not make this a constant. Let's make this a thing in here. And I don't want these. These aren't going to be negative, I don't think. So I'm just going to make them U16s. or it's going to yell at me. I don't really need this to have a size known at compile time. So, I mean, well, so I need it to have a size known at compile time. What I don't need is for it to be an array with a totally sized number of arguments. So it needs to go onto the stack in like a specific size, but it doesn't need to be sized on the heap in any way. There's no whoops, this line is invalid. Oh, yeah. That makes total sense. Advent of Code is pretty good at putting the core questions in bold text. That is also true. Sometimes the details get fuzzy later on. I'll try them with Go. Haha, my Rust is not that good yet. Yeah, that's fair. I mean, like, I think doing the early problems in Rust, if you're learning Rust, is a really good move, because then you have to do things like this, like the Beck and whatever. Especially if you have experience with Advent of Code already. One of the things that I like to do with the questions is I'm actually going to run like criterion benchmarks and stuff on the questions. I don't know that we need to benchmark today's. Today's seems a little bit maybe it doesn't need to be benchmarked. But let's do cfloor iter peekable do we want to do this? I can do this in two ways. I don't know what so one of the things is I don't know what part 2 is going to be. So let's just do the simplest implementation. So let's do for floor in, actually, if we make this peekable, we need a reference to the iterator. So let iterator, or let mute iterator, because we're going to have to call next, equals this. For floor in it, let mute I equals 0. And then we do one equals it.next, which is what we need the mute for. And let 2 equals it.peek, which is what we did the peekable for. So we're using an iterator. We're going over the whole thing. Why is it not? I don't need it.next. I do need it.peek. This isn't going to let me move it in, is it? Rust should definitely let you say all of these things are U16. You count how many there are. Yeah, that's fair, especially for constants. I could see that I could see that being valid. Oh, we're running into iter on this? Let's do this instead. cfloor.iter. I'm just going to clone these. Actually, that won't work, will it? I need the same one. I'm going to go with my original option. What do I want to do here? It's a little annoying. Basically, the problem here is that I'm consuming iterator, but I also want a peek iterator. So I need a reference to the same one. We know how big this is. Oh, LE? No, not LE. Length. I don't need 4 in. I need... Yeah. We'll just make this a range. I'm blanking. I clearly haven't had my coffee today. 0 to range. Expected integer found reference to usize. Yada yada. Okay, so now we have the number of items that we're going to have. We're actually not going to use this. It doesn't matter. So we're going to do the same thing that we were doing before. Let 1 equals it.next. And then we've got it.peak. And we've got match to... I guess we could do if let here, but I like being explicit to start with. Match to... I don't know. Item. I guess we could do both, right? Match 1, 2. So I'm combining these two. I'm combining them so that I get I1, I2. I'm combining them so that I can match on them, so that when we have like some for both of them, we do a thing. When we have some for whatever and then none, we're going to do nothing. When we have, actually for everything else, I think we're going to do nothing. So I'm just going to do this. So we've got some I1, some I2. When we have two values to look at, if I2 is greater than I1, I equals I plus 1. I don't want to exit. Okay. I need to match the level of references here. So you can see the Rust Analyzer. If you're not familiar with Rust Analyzer, it is what's giving me the type inlays here. So I have I1 and I have a reference to a U16, and then I2 is a double reference to a U16 because it's peakable and it's not actually taking it off the iterator. It's just kind of like reference. So I do need to match that. So I can do that in a number of different ways. In this case, I chose to just slap another reference on here. But I could also destructure here, and then I wouldn't need to do that. So if you're not familiar, you can actually destructure references in Rust, which is kind of cool. It does lead to copying, so keep that in mind, but it's usually not a problem, and it's definitely not a problem for primitives like U16. So that says 7. That should be fine. Do you ever use the ref keyword? I have not needed the ref keyword in a very long time. I'm not going to say never use it. I'm just going to say that for my use cases, when I write Rust, I usually don't need it. How many measurements are longer than the previous measurement? Am I not logged into... I'm not logged into the thing. I need to log in. Twitter is how I logged in. Authorize app. I think Twitter is how I logged in. I hope Twitter is how I logged in. Let me go all the way down, get your puzzle input. I'll just copy this in here. U16 should be fine. Oh, this is like 1,000 of them. Maybe I should just read the file in. I'm gonna have to read the file in anyway at some point. We're gonna read the file in. So instead of this, we are going to do fs read. I didn't implement, or I didn't pull in fs. Fs read. Is it read file or is it read? Read to string. And we have to unwrap here. Well, we don't have to unwrap here, but like, come on. This is gonna be like, we're gonna fail hard. File equals this. That comes in. I'm just gonna put a vec here for a second. And then Rust Analyzer will pull this in for me. File file.lines dot map line dot parse. Did I put an extra? I put an extra pipe in there. Oh well. And then dot collect, and this is going to be a vec of U16s. And I think this should all work out, but it's telling me it won't. So what do we got? 16s cannot be built from result. Yes, I get that. So we're just going to unwrap, because if this doesn't work, then we fail. No such file or directory. Did I put this in source? I did put this in source. Don't take it out of source. 1521 is what it says. So that is absolutely correct. So it works. It's fine. It doesn't pass Cargo Clippy. So if you've never used Cargo Clippy before, it'll do things like tell you that you can remove these parentheses, and that you probably should. It'll tell me things like, where is this? Replace I plus 1 with I plus equals 1. So I'll just follow Clippy for the purposes of advent of code, or for now anyway. Let's see what else we're getting here. You seem to be trying to use match for destructuring a single pattern. Yes, I called that out when I did it. I don't know if we're going to need more in the next one, so I'm going to leave it for now. But Clippy is pretty cool. There's a reason they're optional is what I'll say. So don't necessarily feel like you have to run Clippy on all of your code. But I find a lot of them helpful. Hey Yash, how's it going? These are archived, right? Yeah, they'll go up on the YouTube channel. I'm also going to cut them and turn them into a shorter version, so you don't have to watch the entire live stream. I'm going to try to do that every day, but we'll see if I can get it. Okay, so consider every single measurement isn't as useful as you expected. There's just too much noise in the data. Consider sums of a 3-measurement sliding window. Again, considering the above example. Okay, so we have this new input. Start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A, 199, 200, 208. So it looks like they're always 3. Their sum is 199 plus 200 plus 208 equals 607. The second window is marked B, 200, 208, 210. Sum is 618. The sum of the measurements in the second window is larger than the sum in the first, so the first comparison increased. Okay, so we need to iterate over this whole thing and kind of sum some stuff up before we do the calculation. Do you think Rust is going to be required for front-end development? I know it's used for tooling now. I don't think that Rust is going to be required for like the kind of front-end development that people do day to day when they're just learning. Like you're still going to be writing HTML and CSS and JavaScript to get like document-based websites up and running. I don't think that Rust is going to replace that. Where Rust is going to be useful is if you're working on, let's say you're working on like a large project on a team with something like Next.js or something like Nuxt or something like whatever the next huge meta framework is. Those meta frameworks are going to be powered by Rust, so debugging them is going to be easier if you know a little bit of Rust, and working on them is going to be easier if you know a little bit of Rust. And then on the other side of it, Rust will become increasingly useful for things like serverless functions, which are things that we use in the front-end ecosystem quite a bit to do additional functionality and things like that. Make calls to APIs, get around cores, all of that kind of stuff. So I don't think that Rust is going to become required in the sense that it won't be required to build websites, but it will be a requirement if you just start going into the tooling, if you start doing more advanced stuff, if you start writing like a lot of serverless functions. Rust is really nice because it runs typically quicker than the JavaScript or like a corresponding JavaScript version does, which means that you pay less, which means that it runs faster, which means everybody's happier. But no, I don't think it's going to replace like Svelte or React or whatever your front-end framework of choice is. Okay, so we got to do these windows. Stop when there aren't enough measurements left to create a new 3 measurement sum. So is it possible that we won't have like 3? Let me go check the puzzle input. That's the day 1 part 1 puzzle input. Oh, okay. So it's always 3. Interesting. Okay. I thought it was going to like give us random numbers of letters next to these and we were going to have to like parse them out. But I guess it's just 3 of them. So we do need to preview 5 items. So we need to peek 5 items. And I know that itertools has multi-peek. So that'll be interesting. There's no example for multi-peek. What the hell? Iterable, inter-iter, fuse. Reset the peeking cursor. This only takes an iterable. I don't think that that is what we want. That doesn't help us at all, actually. In this example, there are 5 sums that are larger than the previous sum. Okay, so once we have an example that is only 5 numbers, then we stop, I guess. So sliding windows. Let's copy this. I'm gonna make bin. I think it's bin. Part2.rs. And I'm gonna move this in here and rename this to part 1. And then if we want cargo run part 1, that should still work. Yeah, okay, cool. So cargo run part 2, and then this is going to be the sliding windows version. So instead of peaking once, we are going to peak like 5 times. So let's do next in here, it.peak, 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 3, 4, it.peak, it.peak. So we have 6 values here. I'm gonna name these letters for my own sake. A, B, C, D, E, F. So basically, we're trying to take a peek for everything. In the case that we have all of the values, then we can do something with it. Let 1 equals, or I guess we'll do I1. I1 equals A plus B plus C. What did I mess up? We're doing, all these aren't the same. Let's do an extra reference on A, maybe. What's the actual problem here? Not found in the scope. Yeah, fine. No implementation for adding 2 of those. So let's just do this. If I can type today, which is apparently a struggle. Okay, so references, all the addition works now. Let I2 equals D plus E plus F. And then the same thing, right? I think it's going to be, yeah, borrows. Second mutable borrow occurs here. We don't need mutable borrows for these. Oh, I have too many of these. That's why. That feels strange. I guess it's moving it into the match arguments. I'm gonna have to think about that later. Because it works out here. Right? So if I do that, and then I do 2, 3, 4, 5, ice, 5, 6. No, we still get the same error. Okay. So maybe we do need multi-peak. Peak isn't mutable though, right? So like we should be able to reborrow this. Or like it doesn't need to be mutable here. That feels weird. So we have a mutable borrow of the iterator because we need to call next. Peak, I don't believe needs a mutable borrow of the iterator. But takes one anyway. We could not use that there. I don't know that that will really help us. Why am I having trouble with this so many? Next, peak, 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 peak. Second mutable borrow occurs here, which makes sense. Because this is mutable. We don't need it to be. Not for these anyway, but we do need it for it.next. I should have had my coffee today. But why? Like, this doesn't need to be... I'm not going to shared reference the iterator on this. This is going to be next. We're going to peak. I thought I could just peak infinitely. I've done that before. Let me check the multi-peaks thing over here. Maybe that solves that for me. Maybe that's why. I didn't think I needed to do that. I've definitely done this without iter tools before. Yeah, that changes nothing. Because... Oops, that's not what I meant to do. Cannot be borrowed as mutable. Why do I need this to be mutable? I don't need this to be mutable. Peak isn't mutable, right? Oh, it does take a mutable self. I should have looked at that before. Okay. Oops. I mean, like, we can do this. I know we can do this. What did I mess up? I wrote something and then I forgot I wrote it, is what happened here. Okay. The iterator does not advance even if we peak multiple times. This should be valid. Maybe it's because we're moving into a for loop. Still no. I mean, you can do this even in the docs, so I'm a little confused as to what I did. I'm not confused as to why it's a double reference, because we have the iterator, which is a reference, and then we have the value that we're peaking, which is another reference. Returns a reference to the next value without advancing the iterator. Yeah. We can peak multiple times. We should be able to. We apparently cannot. And they take a mutable reference here, right? Yeah. They take mutable iterator on iter. Peakable. What the fuck? We don't actually need iter tools, so I'm going to take that off for a second. Wow. What did I do? I did something wrong. Okay, so it is this. It's the body of what I'm working with here. I feel like this is pointing to... Am I reading the lines wrong? Oh, okay. That was such a weird way to say that error. I mean, like, I didn't read the last part here, so it's my fault. Basically, the problem is that it.peak returns a mutable, like, takes a mutable reference to the iterator, and I guess returns... That's so weird. What is going on here? It returns a shared reference. So I'm not sure why it needed to be mutable. But in whatever case, it did need to be mutable. So mutable borrow places the reference to the value in 1. So I guess we hold this. But we don't actually need these to be like actual things. That's something I'm going to have to think about later. I haven't had my coffee yet. Cannot add that to that. Yes, this is a problem we ran into already. Okay, well, we're back at the same problem. So that's not actually the problem. I just had a different problem. What WTF is my question here? Because I thought I could just peek this. I am gonna figure that out, but there is also an easier way to do this. Tuple windows clones the iterator elements so that they can be part of successive windows. This makes it most suited for iterators of reference to other values that are cheap to copy. Yes, what we want. Returns an iterator over all contiguous windows producing tuples of a specific size. How do we define what size that is? Oh, it uses a type hint? That's cool. So we are going to pull this in. We're going to do tuple windows. I will figure out why you are a problem later. And this can be a whole thing now. So for 1, 2, 3, 4, 5, 6 in this. Then we have our block. This needs to come in. Expected to use 16 bound option. So we don't actually need to do this sum check because the iter tools thing is doing that for us at this point. So match. We don't need to match. There we go. Let's turn these back into letters. E, C, D, E, F. Tuple windows. And we're done. So allegedly the number is 1611. It's not the right answer. It's too high. It's the right answer for somebody else. That's not great. Same puzzle input, right? Oh, they're not overlapping. That's why. I don't need tuple windows. I need overlapping windows or sliding windows. Which is why I was doing the peak in the first place. Let's see what we've got here. Position power is set from sorted by. Tuple windows is what I was using, but it doesn't overlay, so like the windows aren't sliding. Looks like we only have circular and we only have the other one. Filter map, first to last, find position, fold options for each format. Interleave, intersperse into group map, join, smallest, merge, map. Multi-peak. Oh, there's the docs for multi-peak. See, but this shows that it should have worked too, which is really confusing to me. So maybe I just rewrite it. Okay. Let mute it equals this multi-peak. For a and it, can we do it dot peak? I don't know what I did before. I was writing something wrong and I didn't see what it was. Wait, actually, we still may have the error. C D E F. And then this. These are all options now, which is annoying. We'll just unwrap them. Well, no, we can't unwrap them. We have to actually check. Okay. Which means we need to write our match on UCDEF. I don't really want to do it like that though. Let's see, 1, 2, 3, 4. It's going to be the destructuring, isn't it? That looks like it's going to be the same error. Why am I having so much trouble this morning? Save all of that. The function takes ownership of the receiver self, which involves it. Into iter. Why are we calling into? That's not what we want. I just want to see the error. Okay, let me think through this. We need the mutable reference iterator. We cannot call next without the mutable reference iterator. Peak apparently also takes the mutable iterator for some reason. So we have to call next here. This is going to be whatever. This is going to be A now. So we think as soon as we have an F that is not none, then we break. This is going to be some A, which is already a reference to a U16, so we're fine. This needs to be the range again because it's now a number. We are now moving iterator into the loop. That's a pattern that cannot happen. So I'm going to take this, I'm going to move it below this so it matches later. And then we're just going to say the default is to break. Cannot borrow it as mutable more than once a time. Okay, first mutable borrow occurs at it.peak. Cool, totally fine. We're getting a reference to this inner value, which I think is our problem here. Right, so we have a B, which is a reference to the U16. optional reference to the next element struct is created by the peekable method on the iterator. Sure, we'll open that. Peek takes a mutable reference to self and gives us an option that is a reference to the item. But why are we holding on to the reference so long? I'm gonna go check something. GitHub.com rustadventure/2048. I think that's the repo. That is the repo. Okay, tiles. Iter mute is a bevy thing. Sorted peekable. While let. Same problem. As always. WTF. So the match borrows, which for some reason extends this mutable borrow, which we don't need it to do. Okay, so for some reason, this mutable reference lives for so long that it keeps this alive, which is not a thing that I thought I was going to have to deal with. I'm going to fix it in this extremely hacky way and then come back later. Wow, that was awful. Actually, that might not fix it. Well, first of all, it doesn't fix it because we can't unwrap here. There we go. Why can I not take... I have to take a reference here, right? So just thinking through this, right? I have to take a shared reference because peek returns us a shared reference. We could into iter, but I don't think that saves us at all. It does. Oh, that's so painful. That is so painful. So basically, the lesson here is that when dealing with references and not having your coffee and not realizing you're dealing with a bunch of references, these are references to the vec, unless we take ownership of them in the iterator. So really, what was happening here is we were peeking into the iter into the vec, and thus keeping the reference alive, which kept the mutable reference alive. Oh, that was annoying. Why did I do that? Oh wait, actually, we still might be in trouble. I may have just... Why is that an option U16? Oh, right, because I wrapped it in some for no reason. Nope, same thing. What am I doing wrong? Can I borrow it immutable more than once at a time? Yes, I do know that. That is a valid thing. The thing that I don't understand... So, let b equals it.peak. We borrow as mutable reference here. And then we do it again. There we go. We're just going to clone it. So for some reason, these references are keeping everything alive, basically because when we take the mutable reference here, so we take a mutable reference to the iterator, we peek the iterator, which returns a reference to a data structure that's on the iterator, which means that if the option here is a reference, that keeps this mutable reference alive, because technically we're still looking at that thing. So when we move them here, it complains because we're moving them into the scope destructuring and adding them together. But if we just take ownership, or not ownership, but like if we just clone these values, and it's cheap to clone U16, so I'm not too worried about it. That should work. I got the same answer though. So my logic is wrong, which is hilarious. Pretty sure I got the same answer anyway. That's not the right... Am I putting this in the day one answer or something? All right, let's print out the test and see if we get this right. It's going to be input2.text, and this is going to be input-2. We could add this as an argument, but I'm not going to. It's right on that one. Wait, is it not right on that one? Five, yes. So I'm putting my answer in for the other one and it's not working because why? I'm not missing any here, right? So we get the next value. Then as long as they all exist, because we can't do it if it doesn't exist, then we deal with it. You're right. Single quotes and Rust are characters. So I, but no nose. That's weird. Am I running the right thing? Bin part 2, part2.rs. So no previous sum isn't one that we would get because we start off with 6. Then we increase. Then it's supposed to be no change. Ooh. Okay, 607, 618 results in an increment. 618 and 647 results in an increment. 618 and 716? That doesn't seem right. Why are we comparing 618 to 716? Because we're not actually doing this, are we? Oh man, I didn't do that at all correctly. This isn't even 6 values. This is supposed to be 4. Damn it. Oh god. Remember, somebody remind me to have coffee tomorrow. 1, 2, 3, 4. EF. Yada yada. None. A plus 2 plus 3. And then 2 plus 3 plus 4 is the positions that we should be adding. How do we get the right number with the wrong algorithm? Oh, that is so awkward. What an absolute just not awesome thing. Oh, what a trip up for day one. Could you do it like copy the option like it.peak.copy, same as copying a pointer? Yes, because copy will copy the bits of the U16, which is effectively the same thing that I believe clone does for so this should also work. Oh my. And I don't even know why my multi-peaking exists in iter tools, because we don't need it. Right? Like peakable lets you peak multiple times. I don't know why multi-peak exists. Maybe it does something else. It's the same problem a week ago. Yeah. If I could screw my head on straight when I woke up this morning, that would be nice. Even after writing so much Rust, it is still possible to just need to walk away from the computer. Okay, so CD. I don't think there's a sliding window function, but I'm going to look for it now. And so we already have one, actually. That's hilarious. Windows method on slices. So if we don't do this, do Windows, we can do, wait, why is it complaining about Windows? I don't want that. I want this. Oh, right. Expected an argument for. We don't need it.next here then. Don't need this match either. Does that come in as a slice? It does. So Windows will give us all of those, huh? Was the Windows on slices in default Rust standard? Yes. Yes, it was. If we go over, you can see it's on standard slice Windows as the struct, and the function is on the slice primitive type. If the slice is shorter than size, the iterator returns no values. Okay, so why do we have to deal with... That is cool. Yes, it's very cool. Is 1543 the right answer? 1543 is not the right answer. 1521 is the right answer. So this actually doesn't give us what we needed. Let's run this in Rust Playground. Let's take 3 here. RUSST. So if we take 3, I don't want this. I want... RUSUST. That should be the right thing, right? So if we Windows 4, then we get these 4 values. There is no way in which we should need to do more than that, right? We need 1, 2, 3 plus 2, 3, 4. Why does that give a different answer? Gives the right answer on the small stuff. I think my small example isn't actually representative of something. There's something happening in my actual input that isn't happening in the smaller input. Where's the problem here? Click back on 1. So 1, 2, 3, and 2, 3, 4, whole way down. And this is this. Oh, your puzzle answer was 1543. Why did I think it wasn't? No, we're good. We're good. Everything works. This is exactly what it's supposed to be. I'm interested in knowing why Windows can't tell that it's supposed to have 4. I guess it's because it's a runtime thing, right? If the slice is shorter than size, you get none, right? But apparently at runtime, we can't tell that. So we have to do this if let inside, which feels weird. Because it's saying that some patterns aren't handled. So I ran it on the whole thing. Also, welcome back, Nikki. So this works. Happy with that. The peekable thing is something I need to look into. This is a kind of a question mark for me. Because it wants us to match, pattern match on like 0, 1 item, 2 items. I assume 3 items. And then maybe more than 4 items. So I guess we can't, I guess Windows can't propagate the fact that we've asked it for, I guess we're not using tuples anyway. So that makes sense to me, actually. If we have to return a slice, we can't actually know how big that slice is, even though we've put 4 here. So we don't actually get the type safety on the length. So really what should happen here is panic. Slice wasn't length 4, right? Because if this happens, which it should never happen because we use Windows 4, and Windows 4 never gives that to us, we can insert a little panic here. And if it ever does happen, then we know. Let's see, what else can we do here? I don't think that there's really any performance work to do here, so I'm not going to do criterion today. Maybe DAT. DAT could be helpful. We could use DAT for the first time. Although I don't know that that is going to be helpful at all either. Can I post my solution for you to look at, please? If you're done with yours, says, yeah, I'm done with mine. I'm happy to look at yours. I'm going to also order coffee. Are you going to post it in Discord, Nikki? Yeah, okay. Voice chat text or? Yeah. You can either DM it to me, put it in using Rust, put it in the Advent of Code channel. Just let me know which one you put it in, and I'll pull it up. It's still there. Oh, it's the scrapyard one? Okay, cool. Okay, so you did a manual windowing function? Did you have a question about it, or did you just want me to look at it? That's the standard one. Oh, you did use Windows. Okay, there we go. Why did you use Windows 2? Oh, just wanted to show it. Cool. Oh, I guess, yeah, you did sums of 3 measurement windows. And then you did Windows 2 so that you would have like A and B. And then you could just use sum actually if you do it that way. I kind of like that actually. You could have also used flat map. Flat map for up here for instead of filter map, you're saying? You know, I actually like I wonder if there's a performance difference between Windows 2 or Windows 3 and then Windows 2 or just Windows 4. Because Windows 2, 3 is probably more understandable. Let's see, is there any way to improve this? File lines, map, parse. I'm unwrapping, you're doing .ok. I'm unwrapping here because we can't actually continue if this fails. In my head, it sounds like you talked about Microsoft Windows. That reminds me, I need to get the Rust compiler working on native Windows. 1, 2, 3, 4 Windows. Yeah, for items in seafloor Windows 4, then there's this. And instead of doing positives, we could have summed it. I don't know that I care to make that change too much. I do like the... So I do like the readability of doing like, hey, turn this into 3 measurement windows all the way down. And then like take 2 of them. You did compare... You summed them first anyway. Okay, cool. So if you're summing them and you're mapping over them, do you need to collect there? I feel like well, it doesn't really matter because we're dealing with like integers and small stuff, but I think that collectible doesn't need to be there per se. I don't think there's any way that I really want to improve this. I am going to start taking a look at dat now, I think. Yeah, the compiler got angry if I didn't. Okay, so does this write out a file for us? I think it does. It's lazy evaluated. You think collect is lazy evaluated? Collect is consuming. So if you collect, you're forcing it to all come into like a point and create that vec, I think. Unless Rust is smart enough to realize what you're doing, which it's possible that that's true. The Rust compiler is much smarter than I am. And sometimes like when you think about when things deref and stuff like that, the Rust compiler can actually do more complex analysis. I don't want to ad hoc profile. Ah, it'll print standard error. Okay, that's cool. Let's do this. Cargo add that. I've never used this before. I want to use it on a number of the I want to use it on a number of the problems this year and see if I can do a little bit more profiling. I guess we do need to do release, right? So in cargo toml, our release profile will be debug 1. And then this needs to stick here. And then if we cargo build release, what is dat? That's going to be the name of the YouTube video that I create to talk about dat. I don't know. I don't even know if that's how you pronounce it. I just find it hilarious to pronounce it like that. Dat as a high level thing will do some profiling to determine how much you're allocating, basically. So you'll see that when we run this, we'll get some output that's like, hey, allocated this much there, allocated that much there, that kind of thing. So if we go to target, release, part 2, then we get 17, so 18 kilobytes. The title is perfect. Yeah, I'm really happy with that one, actually. I need to make that video. I'll probably make it after I do it, after I use it a bunch in the Advent of Code stuff. The dat heap JSON is viewable with dat dhview.html. Where is dat dhview.html? Okay, so there's an online viewer. Let's see if we can file load. Oop, that's not what I want to do. I want to use the Mac OS open. I'm in new shell. So cargo toml dat heap.json open. Am I using new shell? I am using new shell. I love new shell. It's amazing. There's a couple of things that you can't really do in new shell, but for everything that I can use it for, which is most of my daily driving stuff, I use it. Okay, so I don't know what Gmax is. Growmax, maybe? Is it Starship inspired? Yes, my new shell theme is Starship and Night Owl colors, which is the same thing that I have in my VS Code instance. Yeah. Okay, so the dat documentation It looks like something that I'm going to have to read offline. The second line shows how many heaps and blocks were alive at Tgmax, i.e., the time when the heap size reached its global maximum. So for us, Tgmax happened at 258 nanoseconds, which is about 80% through our program duration. And that's when we had the most allocated, basically, is my understanding. And then T end, I guess, is when everything got dropped. Yeah, the end of execution. How many things were not explicitly freed? So we've got the maximum and the end. The total is, like we said, about 18 kilobytes in 13 blocks. I don't know that we're going to be able to do much about this particular program. But it would be interesting to compare like Nikki's solution with mine and see if they're any different at all. So we went up to a maximum of 14 kilobytes when we were running, and we only allocated 18 kilobytes total, it looks like, if I'm reading this correctly. Mostly in vector allocations, it looks like. I'm not sure what PP 1.13 stands for. The following shows a screenshot of a PP tree. The font is very small because the screenshot is intended to demonstrate high-level structure. I could just take... I mean, I have Nikki's. I could just throw it in. Let's take a look. Raw. Probably better than asking Nikki to do it because I get to use it on the same input if I do it here. So let's do... Nikki.rs. There you go. So input.text. I think that the slower and more memory usage, you think? We're not testing execution performance here at all, for what it's worth. Okay, so I should be able to... Actually, I need to grab the other stuff from here. So these get pulled over. So we changed the allocator, and the allocator is the thing, like whenever you create a vec, it allocates data on the heap, right? The allocator is the thing that does that. If we use the dat allocator, it can track whenever we do that. Does it matter I used U32s? Not sure. I believe that that will cause a little bit more memory usage. But like, does it really matter? Probably not. This is doing part 2, right? Read to string, parse. This is doing both. Let me recompile. Yes, it was more. So we're seeing 35K and 25K at Gmax instead of, what was it, like 18 for the other one? So yeah, 18 and 14. So it's approximately double. If I had to guess, it would be because of this collect. Because if it's just double, right, and the only really the only thing we're doing is allocating a VEC here. So I think you have 2 copies of the VEC and I have 1, probably, that kind of thing. Let's see if we can... change it to a U16. I can do that for sure. Oh yeah, that would be exactly the same thing, wouldn't it? Some is not implemented for U16. Hilariously. So we would have to actually change some of the other code. Oh, some U32 is not implemented. Why are we summing U32s? Let's do U16 here and do we need it anywhere else? Part 2 data, part 1. Let's comment out part 1 because we're not doing it right now. U16. Build. Okay, so it dropped. We had 35 kilobytes before. Now we have 17 at Gmax, which is, I believe, the same. So 17,947 and 17,841. At T end, mine has 0, which I don't know if that was, and at T end, yours has 1,000. Yours is consistently has 1,000 too. Which is interesting. I don't know why that is. I also don't know what kind of delay we're on the YouTube stream. So it's entirely possible that I've already done something. So total allocation is still a little high. It's 22K instead of 17 and 17 instead of 13 at Gmax. I mean, we're talking just to be clear, we're talking kilobytes here. Like we don't care. Not in this instance. But it is interesting to see some of the DAT allocation tracking happening. You're saying that it yelled at you when you did this because Windows is on a slice, not an iterator. Rust for Windows, that's what I wanted. Crap. Okay, so across all crates, we have slice windows. We have array windows on slice. If we are going to do that, I think we have to change that code, actually. Which is probably easy, if I'm being... We're gonna do peekable again. Why do we need that to have a type on it? Yes, it is not that important. It is literally not important at all, actually, Nikki. Cannot index into a value of U16. So comp does bit comparisons. Oh, right, can't index here. So window and so if we do, we actually can't peek this, can we? We don't have a reference to the iterator. Never mind. So Windows is only on slices, which means you have to do it like this. It's strange to me that Windows is not on iterators. That's not actually a thing. What is that person even talking about? There is tuple windows. Tuple windows is not what we want, though, as we previously discovered. Is tuples the tuples windows that I actually wanted before? Return an iterator that groups the items in tuples of up to a specific size. So if we have 1 to 5 dot tuples, and we push that in, then we get 1, 2, 3, 4. That's not what we want. That's the opposite of what we want. That's not the opposite of what we want. It's interesting that Windows doesn't exist for iterator. I wonder if we could find that in like a Rust RFC somewhere. Like Rustlang, Rust. Actually, let's not do Rust. Let's do RFCs. This is going to be impossible to search for, actually, now that I think about it. I am not going to do this. we're gonna back out of this. This is just going to be a whole bunch of resources about Rust on Windows. Okay, so let's take a little bit of a look. Like any tree, it has a root node, leaf node, and non-leaf nodes. Structure of the tree is shown by the lines collecting the nodes. Hey, Microsoft! Subtrees beneath a non-leaf node can be collapsed or expanded by clicking on the node. It's useful to do that for subtrees you aren't interested in. It looks like we don't really have a very complex program here. So like, there's nothing for us to collapse really, except for this one root. This looks like a vec allocation. This looks like another vec allocation. This looks like a vec allocation from the FS. So if I'm reading this correctly, this is 10, that's also 10, and this is 11. So if I look at part 2 and I look at line 10, this is all basically the FS registering. So let me get rid of Nikki's solution so I don't commit their code. And then I wonder if we can get the total allocation down. So if we do Rust file lines, right, read lines, we can read lines without actually, but we still have to allocate everything into that vec because we have to iterate over the whole thing. Right? Because we need a slice to do windows. Because we need a slice to do windows, we can't actually windows on the iterator, which means that even if we read the file in line by line, there's nothing we can actually do about it because we have to collect, or we have to get those contents before we run windows. So I don't think there's anything we can actually do here to reduce the amount of memory usage. And we aren't, like, we don't do anything else. I only allocate the single vec, right? I guess theoretically, there is the file that we read into a string, so we're allocating a string in a vec. Raw vec, C string on 10. String with capacity, there we go, at 10. And then vec with capacity at 11. So we have a string and a vec basically being allocated here. How big is the file? File is about 10 kilobytes. And at Gmax, we have 17. If we go back and look at the... So at Gmax, we have 17, or at Gmax, we have 13, actually. In 2 blocks. This is 12 bytes. This first thing that happens, this read to string, allocates 12 bytes. And then we get 9749. Is that exactly? That is exactly the file size. That is the file. We actually can look at the allocation and match it exactly to what's actually happening. So this is the file getting pulled in. I think this is something else. 12 bytes. 12 bytes sounds to me, I don't know, like a pointer of some kind or something like that, like a really small, like, hey, we're starting a thing. And then we read the file in. So this comes in as a string as 10K. And then we have 8K from the vec. And at tgmax, the vec is responsible for 4,000 bytes. I think when we getting this low, the only thing I'm concerned with trying to, like, really, we're over optimizing this. So, you know, we are over optimizing, is actually like running into word sizes and things like that. It will be really easy for me to go this small, or like on the bytes size level, and miss something like that. So I think I'm happy with this for now. Reading it for today, probably enough. We have identified that there is one string allocation for the file and one allocation for the vec. It's interesting that it's 8,000 bytes for the vec, but only 4,000 at Gmax. So it would be interesting to see what was the cause of that. I wonder if we're over allocating because we're shoving a bunch of stuff into this vec, and we could maybe, if we initialized it with capacity ourselves, we might be able to cut that down. That would be probably low end use case though. Code golf is fun. For sure. But yeah, I'm happy with this. I think I'm gonna call it there. I'll see y'all tomorrow for day number 2, and I will have my coffee. You probably hit some amortization boundary. It doubles in capacity each time. Yeah, that's what I was thinking too, right? Because when we have this vec and we go over lines and we're mapping over the lines and then we collect into a vec, I don't have a good understanding of when the vec gets allocated here and if we are packing lines into it little by little, or if it maps over everything, parses everything, determines how much the vec needs, and then allocates. So that's something that I would have to look into, which isn't really a funny... Yeah, I bet you that's what's happening. I totally agree. 4,000 bytes, it probably tries to like double or something like that. Or one block, average size 4,096 bytes. It probably clamps it down after we collect it. Let's see, iterator collect, traits collect, spec from iter nested. We do a with capacity here in the collect. So I'm not actually sure. But I could go dive into these and figure it out. Like when we with capacity, what are we actually with capacity at? Yeah, happy to look at your stuff. If you are doing yours before I do mine on stream, I'm happy to look at it whenever. So I think that'll be it for today. And thanks for hanging out, everyone.